Hello everyone, in this video I want to add more methods to make this cat class do a lot of stuff like we wanted to. We wanted to add like a purr, eat, play, sleep, all of that, right? So I want to make sure that we introduce that concept into our code. We have not implemented all of this, so I just want to do that now. So we have done this name, age, and ID. We have created Snowbell. We'll create Tiger and Jingle later. And then we want to implement the actions now. So it's the same code. I'm not going to have multiple files this time. It's the same file. We are just adding more functionality as we go. So what I want to do is we created one introductory method. That's all we created so far. I want to add another method. So that will be for eat. Okay, these are three methods. So to begin with, we want to start off easy, right? So we just want to say console.writeLine. Okay, anytime the cat eats, it's going to say my tummy is full. Anytime we ask the cat to sleep, it's going to say something related to that. And then anytime we call the cat to play, it's going to say something like that. So we know that it wants to play. Okay. So this is the easy thing. There is nothing in it, right? Just we just have console.writeLine. How do we call it here? So we have Snowbell. We'll just say snowbell.eat, snowbell.play, snowbell.sleep. Okay, this is just nothing at all, right? We just call it, and now let's see how these methods work. So when you say eat, if he says yummy, my tummy is full. Or we can just say something like thanks for feeding me. Okay, so see, she's saying thanks for feeding me, yummy, my tummy is full. And then when you say play, she says give me a ball of yarn. And then when you say sleep, she says zoom. That's it. Okay, see, these don't have any logic in them, but at least you know how to call a method. That's the whole idea. So now if I really want to make the cat simulate that, so you would have all played games, right, where you have 10 cookies or something that a character has. Every time you call eat, the cookies keep going down in number, and then if there is no more cookie, the character will say, oh, I ran out of food, it's time for shopping, or something like that. So that's what I want to simulate right now. So we want, anytime we have a brand new cat, we bring it in here. Not only do we want to do the name, ID, and age, I also want to give this cat a fixed number of cookies. Okay, in computer, anytime you say you want to give it cookies or whatever, it has to be a variable. Okay, I'm going to call it integer because I am going to count how many cookies this cat has. So I've created a variable to hold the number of cookies that I'm giving to this cat. So how do I give cookies to this cat? I write it in the constructor and I say cookies equal to 10. Let us say I never want anyone else to access this from outside this class. So it can remain as a private field. If I want someone to modify it from outside, then I'll have to make it public. Okay. So now it is private. If I want to make it public, then I have to go and create a property, right? So let's say public int cookies. That's my property, and this will have get and set. Okay, so set, get and set. If you don't have any crazy logic, then we would just say, if there is no validation, we would just say get and set. Okay, if you have some crazy logic or something to validate, then we will say the regular getter and setter, right? We'll have logic like this. So now let's say I just have cookies as a field, and then I'm creating a public option to access these cookies. Now, okay, so let us say anytime a cat object is created, I'm going to set the number of cookies to 10. Remember to put it in both your constructors. So how many cookies does the cat have? To begin with, 10 cookies. Every time you say eat, you want to reduce the cookie by 1. Here you want to say cookies equal to cookies minus 1. Okay? The cat just ate a cookie. Let's put it on the top. So that's why she is saying, thanks for feeding me. She just ate a cookie. Okay? So now, 10 times you feed the cat, the 11th time, you're going to run out of cookies. If you try to feed the cat any more cookies, and if the number of cookies is 0, you can't go any further down, right? So you want to like make sure if cookies greater than 0, else you are already at a 0. So you would just say console.writeLine okay. So this is where we are simulating that every time you call the eat method, one cookie disappears. When all the cookies disappear for this particular cat, then she is going to be like, uh-oh, we don't have any more cookies. Okay, so she can't eat, which means she is going to be hungry. Okay, so we don't have a hunger indicator here. Okay, first let's go and like run this code. So I'm going to put this eat 10 times. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I put eat 11 times just to demonstrate. So let's also write the status of the cookies here. So we can maybe write like how many cookies are balanced. We have so how many cookies are remaining, we are going to know. So let's run this code. Equal to, where is it? Here. Instead of plus, I put equal to, I'm sorry. Okay, let's run the code. What did I do? $38.26, line 38. So this error, I was just taking a couple minutes to look through why this is happening, and I realized, see how I put this parenthesis here? for a property does not get parentheses. So that's the problem why. So now we have no error. That's a good thing. So here's what we were trying to do, right? So I wrote code here saying if cookie is greater than or equal to 0, if we have cookies, then we'll feed the cat. So we'll decrement the cookie by 1. Every time the cat eats a cookie, it will get 1 less. And then it will say all these things. If there are no more cookies, it will say, oh my, we don't have any more cookies. So that was the idea. Greater than 0, not greater than or equal to 0. So it should be greater than 0. So let's run it now. See, the 11th time it says, oh my, we don't have any more cookies. So now we are adding some intelligence. Okay, we are adding some intelligence into our code saying, hey, you know, we are adding some logic inside and adding some intelligence inside, and then we can connect multiple dots now. So right now what happens every time we say eat, we are using a variable to track the number of cookies that are available. And then, you know, when all the cookies run out, this is not going to eat anymore. So eat, or rather feed, right? Feed the cat. That's what we are doing. So if we feed the cat won't be hungry. If we don't feed the cat's going to be hungry. A hungry cat will not sleep or play. Okay. So let's add that logic to our cat. So our cat is going to have a hunger variable. This is going to be a Boolean. So when I say Boolean, a Boolean is a true or false. So whether the cat is hungry or not, we can determine by this variable. So to begin with, so this is a private variable. This is the example of something that will not have a property. We don't want to change this hunger from outside the code. We can feed cookies, we can add cookies to the collection, but we will control this hunger based upon whether the cat was fed any food or not. Okay, so this Boolean hungry. Okay, when we create a cat, okay, we can set the hunger to however we want. We will say false. We will say hungry is false. Initially the cat is not hungry. So let's do that here also. There is no property for it. So that's why we have lowercase hungry. Now, when the cat eats, what happens? It's not hungry anymore. Okay? When the cat eats, it's not hungry anymore. When the cat plays, because it plays, it's going to become hungry. After it sleeps and wakes up, it's going to get hungry. Okay. So what happens now? When the cat eats, it's not hungry anymore. So can it play now? If it's hungry, it's not going to play. Play if not hungry. That's the rule. Okay. So I'm going to say here if hungry, else, if hungry, the cat won't play. So now we are controlling other methods based upon an indicator. Okay. So this is where it becomes really powerful. Sleepy. It won't sleep if it is hungry. If hungry, don't sleep. So same logic goes here. Except what it says here. This is going to be zzz. Okay, so now let's go and like test this out. So here the cat ate 10, 11 times. So it ran out of food, which means it's hungry. Let's take everything out. Okay. So when we create a cat, it's not hungry. So it is going to play. So we'll call play 2 times. Or we'll say play and sleep. So we created a cat. So which means hungry is going to be false. Then we want it to play and then sleep. Let's see what happens. Give me a ball to play. It's saying that, so it's playing. But when you make it try to sleep, it says I can't sleep as I'm hungry. So now it did not work. So now let's feed it. And then we'll call it to sleep. See? I can't sleep, it said. And then we say we are feeding it. It says thanks for feeding me. I have 9 more cookies. And then it fell asleep. Now after it sleeps, you have to feed it. If you don't and you want it to play after it wakes up, it's going to say I'm hungry. I can't play as I'm hungry. Okay, so this is just an example. Just think about how complicated the code can be. What we wrote is like really simple stuff. You could write like a per method or whatever it is that you want to write. Okay. Let's say like you want to like give it more cookie at any point in time. You could do that by saying here so you could assign more cookies like that. So how many cookies? Now he has 19 cookies. It ate 1 time, so it's saying 19 cookies. So you could change the value, but you can get the hungry variable outside. If you do this, it gives you an error. Hungry is inaccessible. So this should be controlled. So this is a really good example where you don't want anyone else to control the hunger. Based upon how many cookies are there and whether the cat eats or plays or sleeps, the hunger level is controlled. Okay. So you don't want anyone external to control it. And so that's the reason why you have it as a private variable and you do not have a property associated with it. Okay. So we saw methods that take no parameter, right? These are all not taking any parameters. Maybe we should write a couple methods that will take some parameters. So let's think about it. What if at a time you don't feed it only 1 cookie? What if you can control how many cookies the cat eats? So maybe it can be a parameter. If you don't say anything, it will just eat 1. If you say a number here, it will eat that many cookies. It could be that way too. So what does that mean? So we will get like int number of cookies can be an input parameter. Okay. Then what happens? Instead of checking for 1, you will, this is how many cookies it is eating. So instead of 1, you will say that many cookies. Oh, sorry. Now you can feed the cat 1 cookie or 2 cookies or 10 cookies. Up to you how many cookies you are feeding it. So you could go in here and say eat. Without updating, if you run, you will get an error. See, it says there is no method that takes 0 arguments. So you have to say how many cookies the cat will eat at a time. See, here it says now. So every time we will say how many cookies. So I fed it 2 cookies, so now it's 18. And then I can feed it 5 more cookies here. So I gave 2 cookies, it became 18. Then I gave 5 more, it became 13. Okay. The one thing you have to remember is when I restart the program, all the data is wiped out. It starts at a clean slate. Again, the number of cookies becomes 20 and everything else. Okay. So if you want to restore the state, that is where we save it to a database and then repopulate it every time. So remember that. Object-oriented programming mainly facilitates it so that it's easy for you to access methods and properties related to a particular object. It has nothing to do with the storage portion of it. Okay, so just remember that. So what I just did very easily without much strain, I changed this eat method to take number of cookies. How many cookies? To take a parameter. Instead of no parameter, we actually made it take a parameter. Okay. Instead of void, you could make this return the number of cookies that are balanced. That also you can do. It's all up to you how you want to do it. But at least you saw how we could write a method. Let me take you back to week 4. Here we had created a calculate speed as a static method. And I said if you have it as a static method, then you don't have to say object dot. So we could directly call the method like here. See, there is nothing dot here. But unlike that, because it's a static method, that's possible. But when you don't have a static method and when our methods are not static, like how I showed you right now, you actually have to call it along with the object that you're calling it for. Okay, so that is why in this main method you can see here we are calling Snowbell's cookies. Here we will have unknowns cookies. Okay, so okay, whatever it is. So each one has their own copy and they manage it themselves separately. So just please remember that. And when you are calling that particular method, so when you call intro from unknown, unknown.intro, see these 3 lines come. That has data specific to this cat, unknown cat. Here we have data specific to Snowbell. Okay, this guy only has remaining 3 cookies. This guy has 13 cookies. So different copies of data that are individualized. Okay, so now you can decide as a cat as a whole, what is available. Can they all purr? Yes, all the cats can purr. But if you want to like write a dog class, that would be a new class called dog, and then you will say dog.sleep, dog.fetch, dog.bark. Okay, so you can like have cat and dog at the same time and you don't have to get mixed up. So let me like really quickly write a dog class and show you what I mean, and it probably won't have all the complications, but I just want to show you like a dog and a cat at the same time. Okay, so we'll auto implement. So I'm not doing any validation here. I just want it to be like quick and dirty so I can real quick show you how we don't get confused about whether it's a dog or a cat. This was what I started off with, right? And then we can just have an intro and a bark method. Oh. Okay, intro will be, and then we could have a bark method. Okay, so now let's go to the main method. So we have cat to cats, and then let's create a dog. You have to say dog, Debo, that's my dog, equal to new dog. And then I can give the name Debo. ID will be 1, 2, 3, 4. Okay, it's not a string, sorry, integer. And then age will be 4, let's say. And then Debo dot intro. Debo dot park. Now let's see what happens. What did I do? Class dog. Constructor is cat. Okay. That's the problem with cutting and pasting. Dog. Okay, let's run it. Cookies does not exist. Where is cookies? Yeah, we don't want cookies or hungry. None of that. We just want it to be really fast. The name hungry does not exist. Okay, where is hungry? Okay, fine. Okay, all good. So see here, my name, the dog, my name is Debo, my ID is this, and then I said bark, all good. So a cat, we are calling the eat, sleep, play. In the dog, there's only the bark method. So now let's go. We know like dogs can eat. So let me call eat and see what happens. Get an error because the dog does not, it doesn't know, oh, not dog, Debo. Debo.eat. If I say Debo.eat, it says Debo does not contain a definition for eat. So what does it mean? Unless I write a method for eat, Debo, even though it's a dog and can normally eat outside in the world, it cannot eat. You cannot call a method like that inside the code. So can you do that for the cat? Can you make the cat bark now? Unknown.bark. We know unknown is a cat, right? Can it bark? It says it does not contain a definition for bark. So that is how we control what methods are available for a dog versus a cat. Okay, so we can find out what type of class you are from inside, and I'll show you that later. But then also the blueprint you're using. With the older code that I demoed you, we did not have any blueprint. Like this guy, cat and dog. There is no blueprint, there is no object. They are just like band-aid solutions put together here. This is like a band-aid solution, okay? There is no cohesive dog object or a cat object. And then these methods can be called interchangeably between a dog or a cat. However, in this solution I showed you just now, nobody that is serious about a cat class, if you are writing it for a specific purpose, you are not going to go and just introduce a dog bark method there, because it doesn't make sense. It is not an action that a cat would take. Okay, so that's the reason why you can keep the properties and actions for a particular type blueprint with it, and it can be separate from the other blueprints. Okay, so dog is a blueprint, cat is a blueprint, and then they may have eat and sleep methods that are similar, but you can customize how you want, what kind of methods and other things you want for a particular blueprint without affecting another one. Okay, so this is okay. In this particular video, at least we saw basically like how to like change this, right, so that it has like a parameter. We saw that part. We also saw how like the dog class and the cat class can coexist, and then you won't get messed up between the different objects because they are having their own blueprints. Hope this helps. Thanks.